Good morning, dear students. Welcome back to physics class. Today, I am going to start a new chapter which is Mechanical Properties of Solids. It is from Volume 2. Today's main discussing topics are stress, strain, and their relationship. This chapter is mainly focused on elastic nature of solid objects. You have to understand that elastic nature of an object is a part of its mechanical properties. What do you mean by elasticity? When you stretch a rubber band, you have seen that it has changed its shape or it has deformed by this external force. And you leave the rubber band or the removal of this force cause it to regain its shape. It will come back to its original shape. This property shown by the rubber band to regain its original shape after the removal of the external force is called its elasticity. In general, it is the property of a deformed body by virtue of which it tends to regain its original size and shape when the applied force is removed. So, this type of materials shown this property is called elastic material. Examples: string, rubber band, etc. And if you apply very strong external force on an aluminum rod, it might change its shape, but it does not regain or get back its original shape after the removal of the applied force. This nature shown by the aluminum rod is called its plasticity. In general, it is the property shown by the deformed bodies which is unable to regain its original shape after the removal of the applied external force. This type of materials shown this property is called plastic materials. Example: putty, mud, etc. There is a one term whose meaning you should know. It is nothing but it is the rigidity. What is rigidity? Those objects which do not deform by the application of external force are called rigid bodies. This property is called rigidity. It describes about the ability of an object to withstand the force applied to that. Or it is the ability of objects to resist changing the shape by the application of the external applied force. From the definition of rigidity, it is clear that practically it does not exist an ideal or a perfect rigid body. You know that steel is a hardest material. Then you can say that it is a rigid body. But I say it is not a perfect rigid body, because the steel bar can be deformed to a little extent when a sufficiently large external force is applied on it. So it is not a perfect or ideal rigid body. Whenever an external force is applied on any body to change its shape, it will develop a restoring force in it, which is always in opposite direction to the applied external force. That is, it always resists to the external applied force. This restoring force per unit area is called stress. For example, when you apply an external force to a rubber ball at the same instant of time, some force develops in the ball which acts in the opposite direction. This opposite force which develops in the ball when an external force is applied is called restoring force. Both the forces are equal in magnitude. How can express it in its mathematical form? It is expressed as stress is equal to force divided by area, which is equal to F by A, where F be the restoring force developed in the body due to the applied external force or deforming force, and A be the area of contact on which the force is experienced. What is its SI unit? Its unit is Newton per meter square or Pascal, and 1 Newton per meter square is equal to 1 Pascal. What is its dimensional formula? It is m L raised to minus 1 T raised to minus 2. These are A. Longitudinal stress, B. Tangential or shearing stress, and C. Hydraulic stress. What is longitudinal stress? It is defined as restoring force per unit area when the force is applied to the cross-sectional area of a cylindrical body. Longitudinal stress are two types. First one is tensile stress and second one is compressive stress. What is tensile stress? It is a longitudinal stress when the length of a cylinder increases. And second one is compressive stress. It is a longitudinal stress where the force is applied to compress the cylinder. Second one is tangential or shearing stress. It is the restoring force per unit area when the force applied is parallel to the cross-sectional area of the body. Relative displacement occurs between the opposite faces of the body. And third one is hydraulic stress. It is defined as restoring force per unit area when force is applied by a fluid on a body which is immersed in it. Consider a rubber ball, and if it is dipped in a pond, due to the pressure of water from all directions, force acts on the ball. As a result, the ball seems to be slightly contracted. Because of this force exerted by the water, there is a restoring force which develops in the ball, which is equal in magnitude to the external applied force by the water, but it is in opposite direction. This type of stress is known as hydraulic stress. And next term is strain. It is a measure of deformation taking place in a body when external force is exerted on it. It tells us how and what changes taking place when a body is subjected to stress. How can express it mathematically? Its mathematical form is strain is equal to delta L by L, where delta L be the change in length and L be the original length of the body. As it is a ratio of two quantities, so it is a dimensionless quantity. Then strain is a unitless quantity, since the units of two lengths, that is delta L and L, will be cancelled by this ratio. For example, if you have a metal beam and you apply force from both sides, the shape of the metal beam will get deformed. This change in length per unit length or the deformation is known as strain. Now, let us see the types of strain. There are three types of strain, which are A. Longitudinal strain, B. Tangential or shearing strain, and C. Volume strain. What is longitudinal strain? It is the ratio of change in the length delta L to the original length L of a body. This body is cylindrical in shape. Its mathematical expression is longitudinal strain is equal to delta L by L, where delta L be the change in length and L be the original length. It may be produced by either tensile stress or compressive stress. Now, let us see the types of strain. There are three types of strain, which are A. Longitudinal strain, B. Tangential or shearing strain, and C. Volume strain. What is longitudinal strain? It is the ratio of change in the length delta L to the original length L of a body. This body is cylindrical in shape. Its mathematical expression is longitudinal strain is equal to delta L by L, where delta L be the change in length and L be the original length. It may be produced by either tensile stress or compressive stress. B. Shearing strain. What is shearing strain? It is the ratio of relative displacement of the faces delta x to the length of the cylinder L. It is produced due to the tangential force or tangential stress, since tangential stress is equal to tangential force per unit area of cross-section. Mathematically, it can be written as shearing strain is equal to delta x by L. So, delta x by L is equal to tan theta, which is obtained by the application of trigonometry. As shown in figure, delta x is the relative displacement between two opposite faces of the given cubical shaped body by the application of the tangential force F. And C is volume strain. It is defined as ratio of change in volume to the original volume of a body due to hydraulic stress. When stress is applied by a fluid on a body which is immersed in it, there is a change in its volume without changing its shape. Its mathematical expression can be written as volume strain is equal to delta V by V. On next, let us discuss on stress-strain relationship. Robert Hooke was a very famous physicist who had studied the stress-strain relationship at first. This relationship was given in the form of Hooke's law. What is Hooke's law? It states that within the elastic limit, stress developed in a body is directly proportional to the strain produced in it. This is a linear relationship between stress and strain. It can be written as stress is proportional to strain, then stress is equal to a constant into strain. Constant is represented by K. It is a proportionality constant and it is also known as modulus of elasticity. Hooke's law is an empirical law and is found to be valid for most materials such as all elastic substances. But it does not apply to plastic deformation because it does not show any linear relationship between stress and strain. Discuss on stress-strain curve. The given figure shows the stress-strain curve, which indicates the relation between stress and strain of a given metallic wire under tensile stress. A graph is plotted between stress, which is equal in magnitude to the applied force per unit area, and the strain produced. This graph helps us to understand how a given material deforms with increasing loads. The curve between O and A is a straight line. This means that stress is proportional to strain. In this region, Hooke's law is valid. So, in this region, the material behaves like an elastic body. In the region from A to B, you have seen that stress and strain are not directly proportional to each other, but still the material has tendency to come back its original dimension after the removal of the external force. That is, they exhibit elastic properties. The point B in the curve is known as yield point, and it is also known as elastic limit, which means till this point the material will be elastic in nature, and stress corresponding to this point is known as yield strength, which is represented by Sy. The region between the point O and the point B is called as elastic region. From the point B to the point D, we can see that stress increases rapidly even for small change in stress. The material does not come back to its original position. At this point, stress is equal to 0, but strain is not equal to 0, as the body has changed its shape. This material has undergone plastic deformation. So, the material is said to be permanent set. The point D on the graph is known as ultimate tensile strength, which is represented by Su. From the point D to the point E, we can see that stress decreases even if the strain increases. Finally, at the point E, fracture occurs. This means that the body becomes in the brittle state. See the main important points which are needed to study from this graph. An object is brittle if the point D and the point E are very close. This means that fracture point is near to tensile strength. Example, glass, which is brittle in nature. Brittle means breakable in nature. An object is ductile if the point D and the point E are very far apart from each other. This means that fracture point is far away from tensile strength. Examples, metals like gold, silver, etc. Elastic substances like rubber have larger elastic region. Other examples are spring, catapult, tissue of aorta, etc. Aorta means the artery which carries the blood from the heart to rest of the body. Substances like tissue of aorta, rubber, etc., which can be stretched to cause large strains, are called elastomers. This graph shows the stress-strain relationship of the elastomer aorta. It is not linear, it is the curved up, which indicates that with small change in strain, the stress produced is largely. Dear students, today's homework questions are given in this slide. Please, you have to work out these question answers by today itself. Okay, thank you. Have a nice day.